All right. Hello, we're going to talk about graphing absolute value and making predictions as we change our function. So we see here we have a parent function, y equals the absolute value of x, and we can see what that looks like on our table. It is going through the origin, and as x increases, so does y. As x decreases, y also increases in this situation. So absolute value is always going to be the shape of a V. And we're going to investigate this a little bit more as we adjust our parent function. Graphing calculators are real nice for this feature, so you want to grab a graphing calculator and give this a try. And you play this out like this. You press Y, and I'm going to do it right now just so I can talk you through that. So I'm going to press Y on my calculator. And then to find absolute value, you got to press Math. And then I'm arrowing over to the word where it says num for number, and I'm going to press enter because basically I'm selecting the ABS, which is absolute value, and then it's going to give me my absolute value bars, and in that case I'm going to type in X inside that, and then when I hit graph it's going to show that graph of Y equals the absolute value of X, and you should see this graph. So when you get a chance to do that, and let's begin to get comfortable with using our graphing calculator to graph absolute value. Okay, we're going to investigate here. I'm not going to use it on my graphing calculator. I'm going to use them just right here on graph paper. And we're going to see how our parent function looks when we make a few changes. Like for instance, let's make a change right here. Let's go ahead and adjust the coefficient. Okay, so we're going to take our absolute value of x and we're going to double it. So -2, the absolute value of -2 is 2. 2 times -2 is going to be -4. Now I'm going to pause and fill this in. All right, when I play this out, I can see my different coordinates is, and we're comparing this to the original one, okay? So -2, 1, 2, -4, 1, 2, 3, 4. Oh, interesting. -1, -2 goes to the origin, and 1, -2, 2, -4. So there's something very interesting happening here. My parent equation did this. And so there's something curious, and this is what we're exploring, is what happens when you have a coefficient. What does the coefficient do? What does it do when it's negative? And actually, let's take a look at this. I'm going to look at my original one. My original one is going to look like this. 1, 2, right there. It rides up along this. So let's maybe compare the differences. So when you look at these two, does it change? It inverts it, so it puts it upside down. And let's consider the size of it. Let's look at the size. Let's see if the size indeed changed. And it did. Let's see if you recognize that. I'm going to go ahead and plot this next one where my coefficient is negative, and it's a -1/2. I'm going to play this out and graph it, and we'll talk about it. All right, so I plotted these out for if my coefficient is -1/2 with an absolute value. And I'm going to plot these. So -2, -1, 2, -1, -1/2. It goes to the origin. Okay, this is really interesting. So it seems like when I'm playing this out, if my coefficient is negative, I'm finding I have an inverted V. And something also interesting happens here is if you look, when I double my coefficient, something is happening here. And then when I am using a fraction of a coefficient, something else is happening to my graph. Now remember, my original looks like this. So you can see that my coefficient does change things. The negative changes something, and the value actually changes something. Okay, so I'm going to go ahead and press pause and fill in for number 3 and 4. This time my coefficient is positive, so my guess is it's going to be in quadrant 1 and 2. I'll play them both out, and then we'll kind of just make some comparisons together. So I'm going to press pause. All right, let's take a look at this one. Number 3 is saying, so I have and 2 things I'm looking for when I have a positive coefficient with my absolute value and a fraction. I'm plotted that out in red. So right here, I can see what's happening. So when I have a fraction coefficient, it looks like my graph gets wider. My V gets wider. And then when I look at a positive coefficient and I'm doubling it, it looks like that my V gets more narrow. It's kind of the opposite of what students believe. So that's something to kind of keep an eye on as we explore this and investigate that. That coefficient does have an effect on our absolute value. If it's positive, it's negative, and then if it's a fraction or if it's larger than 1, it does affect our graph. Now let's look at these ones. So another thing we're going to explore, so now that we've checked the coefficient, let's look what happened if we adjust something inside the absolute value. Like what does it do when we adjust the number that's being part of the absolute value? So for instance, let's go ahead and just try out number 1, and we're adding. So let's see what happens when we're adding. Okay, I'm going to go ahead and I'm going to press pause and fill out number 1, and we'll see what. All right, this is really interesting here. So I included in black here the parent equation here. So you can see it in black, but in blue here, I played out my table that if I have x plus 2, the absolute value of that, this is what I see. Now, it looks like a linear relationship, but I know absolute value creates a v. There's no coefficient, but actually there is a coefficient. It's just 1 and it's positive, so it makes sense that my absolute value is in quadrant 1 and 2. But I'm going to include a point on here just so I can see where it shifts. 1, 2, 3. I'm going to try -3. So if -3 plus 2 is -1, then it is 1. So -3, 1. And I can see this is when my graph starts to turn upward. Now notice the size, you can kind of tell by the slope of this. It's going 1 to 1, 1 to 1. So I notice that the size did not change, but the graph did change. In fact, it moved, and that's something you're trying to keep an eye on. Okay, we do have our parent equation here, which I already have in black. So that's sitting nice on the origin. I'm going to go ahead and work out this one right here. Something we're going to pay attention to is we have a subtraction sign. So let's see how this plays out. I'm going to press pause, run the math, and graph it. All right, when I plot this out, I really had to pay attention to the negative when I went on here. So just be careful of that one. And then the absolute value pushing it to the positive side of it. So when I graph that, I see that my graph, it kept it the same size. I see that my coefficient right here is positive, so it's going to be in quadrant 1 and 2. But I see that it's going to be a v because I'm working with absolute value. So I'm going to try 1, 2, 3. I'm going to try what happens if x is 3. If x is 3, 3 minus 2, it's going to be 1. Absolute value of 1 is 1. So 1, 2, 3, 1. That is where my graph turns upward. So I can still see absolute value playing out in my graph. I did have to play out one particular point. Is there another one? I think that's it for these ones. Okay, so something we looked at was the coefficient. If it's positive or negative, how that affects my graph. If it is a number larger than 1, and if it's a number less than 1, how that affects the graph and affects the size of it. For this investigation here, we explored out to see what happens inside the absolute value. If you're adding a number to x, how that changes my graph, and what it's doing is it's keeping its size, but it's relocating, it's shifting it. Mathematically, we call that transforming. And number 3, we can see that it did transform. What's interesting here is that it's negative, and number 3, it shifted to the right. It kind of shifted to the positive. For number 1, it added 2, and it ended up shifting 2 to the left. So you can even start to make predictions on what your graph is going to do. Kind of plan ahead when you understand what these things are doing, when you do enough of them. All right, so now we've seen those things. Now we're going to look at something else. We're going to look at how about if you add outside of the inequality. So we're not multiplying with the coefficient. We're not doing something inside. We're actually doing something outside of the absolute value. So I'm going to play this out. I'll put our parent equation in, and then I'll go ahead and work out number 1. See what happens. You got to see a whole lot of dot making. Well, there you go. There it is. So I'm going to plot this out here. I'm going to connect my lines. Now look at it's the same size, which is really nice. But I can see that my plus 2 is doing something really interesting. It kept it, and it just shifted from the origin up 2. I have my parent equation. Now I'm going to go ahead and do number 3, work out the table, plot it out, and this time I am pressing pause. And then you can see what happens. All right, for number 3, I had to change something so I didn't graph the same equation as number 1. Number 3, I changed it to subtraction. So it's the absolute value of x minus 2. That way I can make a comparison. And that shows up in red on my graph. And I notice that when I'm subtracting 2, it indeed kept the graph the same size because my coefficient changes the size of it. It kept it positive because my coefficient is positive, and it shifts it down 2. Which is really interesting. So you can kind of pay attention. Again, as you work with absolute value, you can start to make predictions based upon what's being added or subtracted on how my graph is going to be transformed. And here's a couple of examples. These transformations, they don't always happen separately. They can all be combined at the same time. You can look and something can happen. So I can look at this. So in blue is my parent equation. But I look at this guy and I can see, okay, it's a 2. And remember, if my coefficient was larger than 1, my graph kind of shrunk. It tightened up a little bit, got more narrow. It is positive, so that tells me that it is going to be in quadrant 1 and 2. I see the absolute value of -4 here. So if I remember right, when I've subtracted 4, that means it shifts 4 to the right, which it did. And then when I said add 3 on the end, that means it shifts up. So these are some things you start keeping track of. So we got some shifting going on up and down. We have some shifting going on left and right. We have some size changing and some inversions kind of happening. A lot to keep an eye on, but as you practice this, you do get better at it. The parent function is always going to be y equals the absolute value of x. And here's some stuff that's going on, and this is just what we talked about. Okay, this is just some great mathematical language that talks about what we just said. How your coefficient, right here, your coefficient's going to tell you about the size, and your coefficient's going to tell you about it, what quadrant it's going to be in, or at least if it's pointing upward or if it's pointing downward. This number right here, your h is all talking about movement, and k is always talking about movement. And it's just some things you need to be able to keep track of. What's kind of nice is our graphing calculator does this for us. When you let your calculator kind of put that in, and you can see right here, this graphing calculator presented our parent function going on. And I want you to give this a try. Graphing the equations, y equals the parent equation and this. And then I want you to try the parent equation, but adding on the end. And we can see, we can start to predict the equation, how much it translates from the parent graph. Remember what we talked about? So this -3 and this +3. Right, the -3 will shift my graph down, probably down 3, so it's going to look like something down here. I think that was 4. This +3 is going to tell me that it's going to be the same graph, but it's going to move up 3 in my equation. Graph this particular equation, so this one also is telling me something interesting too. It's going to tell me that, remember, this one's really, this is going to tell me about pointing left to right, but remember, it's kind of the opposite. So this guy is indicating to me that it's going to move 2, but it's going to move 2 to the left. So 2 to the left. And this guy right here is also telling me that it's going to shift right and left, but this is telling me I'm going to move 2 to the right. And we can play that out too if you follow your algorithm for using the graphing calculator. And this is how it plays out. Make sure when you put your x in, you're just going to put +2, or you're going to put -2. Now in this graph right here, this guy right here, I'm going to press pause and see if you can tell me what's going to happen on this one. All right, how'd you do? Because of my no coefficient, I know it's the same size. Because the coefficient is 1, I can see that it's going to be, the v is going to point up. This -2 right here tells me that it's going to move to the right 2, and this +3 is telling me it's going to move up 3. All right, let's press pause, and I want you to see if you can match the equation with the graph. All right, how'd you do? Let's take a look at these. So you can see your graph, your absolute value graph shifting up and down and right and left. And notice they're all the same size because the coefficient on there is 1, and that's a positive 1. So that's why my V is pointing upward. And I think that is it. Excellent. Absolute value and graphing calculator gets easier as you practice it, as you do more of it, as you start to recognize the graph. So just keep practicing that out. All right, I'm going to go draw a bunch of circles on my kneecaps.